Hi everyone, today we're talking about the introduction of geometry, which is basic definitions of points, lines, planes, and angles. First thing we're going to talk about is what each of those are prior to going through the figures that we have here. A point is literally a dot. It's represented by a dot. A line is any 2 points connected, and it must go on forever, so it would have 2 arrows on it. A plane is a flat surface like your desk. Any 3 points create a plane. A ray is directional, and it's a point and an arrow, so it has to have a point and an arrow. And then a segment is a part of a line with no arrows. An angle is created by 2 rays, which we will talk about in a little bit. So 3 points in the figure. Points are always denoted by capital letters. So in our picture here, which is what we're looking at, P would be a point, C would be a point, and Y would be a point. They are all dots on the plane. The plane is a flat surface. A lot of times they'll draw a rectangle, and in the corner there'll be an italicized letter. That's the name of the plane. This would be plane M. You can also use any 3 points positioned on the plane to name it as well. So I would also accept plane PCY in any order. Name a line in the picture. There are 2 lines here. One is denoted by a small italicized letter, so you could say line B. The other line in the picture is denoted by, you could say it's line little z, or you could say line PC, and we would put 2 arrows on the top. So when you talk about these different vocabulary words, you want to put the small, like mini version of it above it. So like if I'm talking about a line, PC, I want to draw a little mini line above it. If I'm talking about a ray, I want to draw a little ray. This is what we're going to talk about next, which is a ray. So there are 2 rays in the picture. One from C through P, and then the opposite direction. Rays are directional. So you can actually get 2 rays out of this same line, because one ray would be CP, the point C going through P, and then the other direction, P through C, which would be PC. Notice above I put the little markings for a ray, which is just one-sided arrow. Now a segment is just part of a line. So we had 2 lines, but the one I really can denote as a segment would be just a part of it, which would be from P to C. PC is a segment, just has a, notice there's no arrows on it. I can list it like that, or I can write it as CP, but they are the same segment. That's different than the rays. Ray CP is different than ray PC. They are directional. Now we're going to talk about angles. So an angle is created from 2 rays. An angle is created from 2 rays. So angles can be listed as their vertice, which is where the 2 rays meet, or listed in order from ray to vertice back to the end of the ray. Name a right angle in the figure. Right angles are 90 degrees. This little box means 90 degrees. So I know for sure my right angle is going to be angle AOB. When you list angles, the vertice must be the middle letter. And then notice I have a little angle symbol. Just means angle AOB. Next one, 2 acute. Acute are small angles, smaller than 90 degrees. Like BOC, like COD, and also like AOE. But I only need 2 of them. So I'm going to say angle BOC, and angle, just for fun, I'll do AOE. AOE. They have to be less than 90. How do I know that these 2 green ones here are less than 90? Well, supplementary to that would be AOB. AOB and BOD are on the same line, which make them add up to 180, which means if I subtract 90, these 2 cannot be more than 90, and they don't even look that way. Our pictures will be fairly accurate on this. Name two obtuse angles. Obtuse are larger than 90. So that would be something like AOC, that's obtuse. And also I'll change colors so you can see it, EOB. They're both bigger than 90 degrees. So let me write those down. So we needed, what did I say, AOC and angle EOB. Now you may say, hey, can I call that BOE? Yeah, you can flip the letters around when we're talking about an angle since it's not directional. The directional one was ray. Ray you needed to have in the correct direction. All right, I'm going to erase the picture again so I can mark it up again. We're looking for complementary, which means add to 90 degrees. And the only two I've seen here that are possible to add to 90 are the two here, BOC and COD. They have to add to 90 because they are supplementary or on a line with AOD, a straight angle, which means they have to add to 90 degrees to add up to the total of 180. So it's going to be angle BOC and angle COD. And then lastly on here, it says two pairs of supplementary. Supplementary mean they add to 180 degrees, which I've talked about a couple times right before here. So let's look at some options for us. They have to be they have to add to 180. So a straight line is what we're looking for. Here's a straight line. So we can find two angles that add up to be the blue line. And let's do another straight line here. And we'll find two that add up to be that line. But we'll do the blue line first. So first, we'll do AOC gets us to that point. AOC, and we'll finish up with COD. You see how that creates the straight line or the straight angle, all the blue? Now let's do the same with the red. So we're going to do the same with the red. That was the one I wanted to use. So that's a pair. A pair, like a pair of socks, you needed two of them. So then here's the second one. I'm going to do EOB. And how would I finish EOB? Well, it needs to add up to 180 BOC. The last part of today's lesson are talking about vertical angles. Vertical angles are diagonal from each other. When any two lines intersect, you've created vertical angles. So like this angle and this angle would be vertical to each other, or this angle and this angle would be vertically to each other. And what's unique about vertical angles is that they are congruent to each other. Congruent symbol looks like this. That just means, it's a fancy way of saying they're equal to each other. Their measures are the same. So in the figure, they give us that 3 and 4 are vertical angles, and that 1 and 2 are vertical angles, meaning the ones that are vertical are equal to each other. So then it says if, in the first part, if the measure of angle 1 is 130 degrees, what would angle 2 have to be? Well, I just told you they were congruent or equal, so that's easy. The measure of angle 2 has to be 130 degrees as well. Why? Because they're vertical angles. Now let's discuss the next question. It says, find the measure of angle 1 is, or if the measure of angle 1 is 130, which we just saw, find 4 and 2. So we already know 2. 2 is 130, and we have to say why. So why did we know angle 2 was 130? Because it's vertical angles. Vertical angles are congruent. And that's a bad symbol, but I didn't draw it really nicely. I'll fix it. Vertical angles are congruent. And then secondly, it says, what about angle 4? Well, earlier I talked about things being supplementary. Supplementary if they're on a line together. 2 and 4 are on a line together, so that means they add up to be 180. So I would take 180 minus the 130, and that's going to get me the measure of 4, which is going to be 50 degrees. And then we have to say why, because it says name the property used. And we'd say they are straight angles that are supplementary. And supplementary means they have to add to 180 degrees.